Hi everyone, here are your notes for section 8.4. We're going to be getting into properties of rhombuses, rectangles, and squares. So we talked about parallelograms last class. Now we're going to get into specific types of parallelograms. So first and foremost, we have what's called a rhombus. I don't know what just happened there. So the definition of a rhombus is a parallelogram with four congruent sides. So what makes a rhombus special and unique from just any ordinary parallelogram is that it has four congruent sides. Our next shape is a rectangle. A rectangle is a parallelogram with four right angles. So what makes a rectangle unique from just any other parallelogram is that it has four right angles. And our last is a square. A square is a parallelogram with four congruent sides and four right angles. So kind of like if a rhombus and a rectangle had a baby, they would create a square, right? So a square has both the same features of a rhombus and of a rectangle. So here we're going to do some examples where we're going to classify the special quadrilateral and explain our reasoning. So we do have opposite angles congruent, so I know that it must be a parallelogram. Because it's a parallelogram, I know that the opposite sides must be congruent. So if this side has a single tick mark, then that side must also be congruent to it. And if this has a single tick mark, then that must have a single tick mark there. So now all the sides have single tick marks on them, which makes it either a rhombus or a square. Well, I don't have anything about all the angles being congruent because if all the angles were 90 degrees, then they would all be congruent. So it can't be a square, which makes it a rhombus. So this is a rhombus because opposite angles are congruent. So the shape is a parallelogram which makes opposite sides congruent. Therefore, all sides are congruent, which makes it a rhombus. Okay, a lot of thinking there just to get a rhombus, huh? All right, so here we have some theorems. A parallelogram is a rhombus if and only if its diagonals are perpendicular. Do you remember what perpendicular means? Perpendicular means intersecting at a right angle, right? A parallelogram is a rhombus if and only if each diagonal bisects, remember bisects from yesterday, cuts in half, makes two equal parts, bisects a pair of opposite angles. So if we're bisecting an angle, for example, if this is my angle and it was 60 degrees and I bisected it, then each half would be 30 degrees, right? That should be a 0. A parallelogram is a rectangle if and only if its diagonals are congruent. So remember, diagonals are the sides that go from one angle to the other one in opposite directions. So that diagonal would have to be the same length as that diagonal if it was a rectangle. So for this first example or second example, find the values of x and y. Okay, so let's start with x first. I know I have a rhombus because all the sides are congruent. So maybe we should do y first because we're looking at the sides there. So what would I do to solve for y? Just set them equal to each other. So 6y minus 5 is equal to 3y plus 7. Subtracting 3y from both sides gets me 3y minus 5 is equal to 7. Adding 5 to both sides gets me 3y is equal to 12. Dividing by 3 gets us our y is equal to 4. Now let's go inside the shape to the angles. So here I have two angles. Notice that my two angles are right next to each other. They're not opposite of each other, they're right next to each other. If they were opposite of each other, then we would set them equal to each other, but they are not. So we are going to add them together. So 2x minus 1 plus 127, and set that equal to 180 degrees. Please do not ever, ever, ever add sides and equal them to 180 degrees. Only add angles that are right next to each other to 180 degrees. So that gets me 2x plus 126 is equal to 180. Subtracting 126 from both sides gets me 2x is equal to, what would that be, 54. So dividing 54 in half, half of 50 is 25, half of 4 is 2, so that gets me 27 for my x. Ooh, this one's looking funky. What shape do we have here? Well, I have 4 tick marks that are all single, so I know I have either a rhombus or a square. Take notice that I have right angles in all of my angles, so I know it has to be a square. So this is a square. Okay, so we have a square. So let's look at what we've got going here. Let's get our x's first. So here I have an x, here I have an x. They do not have little degree signs on them, so they're just side lengths, which makes them equal to each other. So 2x plus 1 equals 4x minus 7. Subtract 2x over, gets me 1 equals 2x minus 7. Adding 7 over, gets me 8 is equal to 2x. Dividing by 2 gets me x is equal to 4. Would be my final answer for that one. Now let's go into our y. So notice my y has a degree sign. So which angle does my y represent? Well, it's this angle right here. So what did we say about diagonals of a parallelogram? They're going to bisect each other, right? So we know that diagonals bisect each other. What else do we know about a diagonal of a rhombus, right? So a rhombus, we said that the diagonals bisect the angle. Oops, that's not, I didn't write the angle. Well, whatever is true for a rhombus will fizzle down to a square. So that means that this angle is being bisected. Well, the whole angle is 90. So that means each of these sections is going to be 45 degrees. So if I know that that angle that our 7y plus 3 is pointing to needs to be 45 degrees, and let's set that equal to 45 degrees. So 7y plus 3 equals 45. 7y is equal to 42. Y is equal to 6. Okay. Why did I know? Well, because I know my diagonals are perpendicular too, right? So let's just kind of like break this apart here. Think about this for a second. So because it's parallelogram, I know that the diagonals bisect each other. Because the square technically is a rectangle too, I know my diagonals are going to be congruent. So each of these halves are going to be all the same. So do you notice how now I have a right isosceles triangle? So if I have 90 degrees up here, 180 minus 90 is 90. Cut that in half, tells me each of these has to be 45. Right? That's another way you get to that 45 degrees. Just some food for thought. All right, here we have the diagonals of rhombus PQRS intersect at T. Given that the measure of angle RPS equals 30 and RT is equal to 6, excuse me, find the measure of angle QPR and the measure of angle PQS, PT, QT, and PQ. Whew, we're finding a lot of information there. All right, let's just start filling in things that we do know. So I'm told that I have a rhombus intersecting at T. So if this is 6, then I know this must be 6. If this is 30, then I know this must be 30. Because it's a parallelogram, then I know that the angle opposite has to be exactly the same. So this has to be 30 degrees, and that has to be 30 degrees. Because it's a rhombus, I know that the diagonals are perpendicular, so that has to be a right angle. And then I have a triangle right here that I know all 3 angles should add up to 180 degrees. I already have 2. 90 plus 30 is 120. When I subtract that from 180, I get 60, which makes that have to be 60, which makes this have to be 60, which makes that have to be 60. All right, so let's start finding some stuff out here. The measure of angle Q, QPR. QPR is QPR is that angle right there. So our answer is 30 degrees. What else do we need to find? The measure of angle PQS. So start at P, go up to Q, end at S. We've got that labeled, 60 degrees. Okay, what's PT's length going to be? So PT, is that right there? So 6. Oops, I want to get rid of that. PT is equal to 6. What else are we finding? QT. Where is QT? Ooh, QT is right here. Oh boy. Bring back some trig into our lives. All right, so we've got QT. I'm going to recreate this triangle. QTR. This is 30 degrees. This is a right angle. This is 6. This is X. How do I solve for that? We're going to use some trigonometry, aren't we? Is my hypotenuse into play? Nope, it is not. So we can't use the sine or the cosine. Remember, so, ka, toa. So we're using tangent. So I'm going to do a tangent of 30 is equal to x over 6. I'm going to get my calculator out. Type in the tangent of 30 and I get 0.577 is equal to x over 6. Put that over 1. Look on this diagonal. No x's. I'm going to multiply by 6. So x is about 3.5, I'll say. So QT is about 3.5. So what would PQ be? Oh, now we're going to find PQ. Whoo, PQ. We can do this, guys. We can do this. All right, let me erase this. All right, let's look over here. So PQ, I'm going to recreate this triangle. It kind of looks like this. 6, PQ is here. Again, this is 30 degrees. So now we're solving for a hypotenuse. We're given an adjacent. So we're going to do a cosine of 30 degrees is equal to x over 6. Cosine of 30 is 0.866 is equal to x over 6. Put it over 1. No x on my diagonals, just multiply. So that gets me 5.2 if I round to 1 decimal place. So PQ is about 5.2. You thought you were done with it, didn't you? But it's back. All right, that concludes your notes.